It's my pleasure to introduce Mr. Prabhat Goel. Mr. Goel is Industry and Technical Advisor at Eurovent Certita Certification for over 2 decades of experience in HVAC industry across India and Middle East. Coming from mechanical engineering background, he has previously worked with prominent companies such as Carrier, Voltas, and Johnson. Mr. Goel has professional expertise in various areas, including carbon footprint reduction of buildings, HVAC controls, IoT, indoor air quality, digital transformation, etc. With his extensive background and specialization, Mr. Goel brings valuable insights into optimizing energy efficiency and enhancing indoor air quality in buildings. Today, Mr. Goel will briefly overview us about HVAC energy efficiency with IoT technology. Please join me in welcoming Mr. Prabhat Goel.
The topic of IoT integrating with HVAC is nothing new. I'm to say it's been going on for quite some time. And previous to this, we had the BMS as told by Gautam. And today we are embarking upon something different, something new, which we call as IoT. So the first thing to understand is what did BMS have that IoT doesn't have, and what does IoT have that BMS didn't have? Because otherwise, we are repeating a cycle which has probably gone on for 20 to 30 years. So on the BMS front, probably I started in as early as late 80s, 1991, before the Kuwait War. We had already started transmitting data from hospitals in Kuwait into the service center in Kuwait. And as the modems progressed, we started getting the data faster and faster. It went digital. And then the internet started showing up in a good way, and more systems started getting connected to building management systems through internet. And we spent a lot of time integrating stuff from DG sets and security and fire alarm and what have you. And there was a lot of protocol transfer, a lot of time spent on that. And then the backnet came in, and the whole thing became quite, I would say, complicated at some point of time, to the extent that if you lost your person who had set up your BMS, then you lost half the information that you could get from the system. Added to this was the fact that while you could archive data, and this is what I'm saying is very, very important, while you could archive data onto your hard disk and then pull the data back to draw charts and graphs in order to really utilize that data for any of the energy saving algorithms, it was lesser said or lesser done than said. I'm to say not much data was archived, not much data was pulled back. Although BMS was offered basically as an energy saving tool, it became a very expensive look into the system, a window into the system, with all the jumping and dancing figures over there showing that the pump is running and water is flowing and air is flowing. So for a long time, the utilization was basically to look into the system. And then as things started becoming wireless, a lot of the sensors started connecting directly to handheld systems. Today, we use basically the cell phone as the end at which we look up the data. And along with that, it's not only shown in a number form, but you can very quickly go to a screen where it will give you the last month or the last 7 days or the last day's data in a graphical form. And that is what brings you a way of looking at things where you can really analyze as to what is going on in your system. my suggestion to everyone who's on this particular program is not to basically jump to the sky and create a hype about it. Internet of Things is bringing in some very simple to very complicated devices. Start with the very, very simple ones like temperature monitoring, humidity monitoring, lux levels monitoring, your energy data monitoring. And these can be done by very, very simple devices, probably bought off the net from in the US from Amazon.com. There is lesser offering on Amazon.in at this point of time, but that's your starting point. And it will certainly help in making systems simple and more accessible. And really, every drops makes the ocean. You will find small things in my presentation when I do about what we call smart outlets. And these are nothing but digital out that we used to use in BMS systems. The temperature sensors are analog in and digital in. But the difference is that they don't go right up to some particular point and then come back to your screen and things like that. They connect directly to your app, and you can have 10 apps running out of your smartphone. And then, of course, comes programming and other things, which is a level 2. And you can take correct actions based on the data that you are getting. The third level and the fourth level will come where you will go into MI, to artificial intelligence and algorithms and machine learning. Don't jump into those particular things and create a hype. Start very slow and steady. It's like a child learning to walk before it starts running. And that is what will get us the results of all this decarbonization that we talk about. I'm to say data is, at the end of the day, data-driven decisions and data-driven everything basically is the order of the day today. I'm to say a lot of the time we've been talking, this is done, that is done, this has happened, that has happened. And soon as we try to find data, well, it's missing. In 1 or 2% of the cases, we could get actual building data. 98% was design data. So in future, if you want to get the data, archive it, analyze it, I'm to say this is a simpler path. So HVAC energy efficiency with IoT. Energy efficiency, this is a curve or a bar which is shown. I'm to say we need to understand our kilowatt per ton and COP, both for the equipment and for the system. And say system COP is not the same as equipment COP. So here we are talking more about system COP than just equipment COP. There are different kinds of HVAC systems that we use. Simplest is room air conditioner to a district cooling. And the COPs that we get in different systems are different, air cooled versus water cooled. Probably most HVAC engineers know what kind of COPs we should be achieving. Now, it's very important for a HVAC engineer to know what causes a loss of efficiency or parameters that can affect your vapor compression system for system efficiency. And they could be different for different equipment like water-cooled chillers, air-cooled chillers. In a water-cooled chiller, it could be as simple a thing as oil migration to the cooler. Very little talked about, but if oil migrates to your cooler, your COP goes down. In air-cooled chillers, loss of charge, it's an air-cooled condenser takes place and your COP goes down. Both the systems can suffer from low delta T syndromes. Water-cooled package units have their own problems. Air-cooled package units have their own conditions. Even air handling units, dirty air filters can end up making you consume so much more power than what you want. Oversized fan motors with lower fan efficiency, once again, the same results. Cooling towers run in a very bad condition most of the times. And dirty tower can reduce the approach and affect your system efficiency. And we all know now that controlling operational energy is very, very important. The first cost or first bit of carbon is one bit, but operational carbon is the most important thing. Now, in the past, we used to do all these things with these very, very simple devices, which we could master. We are talking about relays, timers, sequencers, thermostats, and things like that. And then over the years, we shifted to BMS and we started integrating stuff. And it really got out of the hand of HVAC engineers, went into more into BMS specialists. Now with IoT, what is happening is it is coming back into the hands of the HVAC engineers. The chiller monitoring, the chiller manufacturers are selling a simple program with a connectivity. You can look up all your information from the chiller, not only entering water, leaving water, condenser, how many amps it is drawing, if there is an alarm or not, but entire parameters standing in the field. And this is a picture from an Indian company basically monitoring chillers standing on the rooftop. Again, the pumps are getting much into IoT. People are offering pumps which are IoT enabled, and you can get the data directly. Control companies, this is a totally new technology which we call NFC. It is just like your credit card, basically, that you use your tap credit card at McDonald's. You bring your handheld phone next to the controller and you get all the data. That's where we have come to. And basically, IoT now is analytics powered, which makes all the difference. And here is a quote, like digital tools and sensors are key to enabling the transformation of urban energy systems to reach the net zero goal. So that's how important IoT is going to be in the future. Now, here is a simple temperature sensor. You hang it out and you have a hub and you get onto basically the app on your phone and you can see. Now, Gautam had very clearly said that different people get adjusted to different temperatures when we come to adaptive cooling. But how do you know what temperature do you get adapted to? What is your comfort point and what is not? And now with these particular very simple tools, you can get that particular thing. So adaptive cooling will become more into people's reach by using these simple systems. Again, you don't need a full-blown BMS to do these particular things now, like CO2 level sensing and increasing the fresh air quantity, etc. And remote starting, stopping chillers in order to reduce energy. Reading the delta T of a system. You can sit in your office and look at the delta T with probably a system that costs less than 10,000 rupees. And say you can just set it up at site, come to your office, open your handheld phone, and you will see your entering, leaving water temperature all along. So delta T monitoring your cooling tower. And last but not least, this is what is an energy monitor. So energy monitoring is also possible with very, very simple systems, which are installed up to 100 kilowatt motor using 3 CTs if it is 3-phase, and you monitor it sitting on your laptop, basically. Time allows, at the end of the program, I will give you a live demo on a handheld energy monitor, which I have set up, and it's all IoT based. So time that our engineers learned this, got started, we are trying as part of IIE, which is ISRE Institute of Excellence, to set up hands-on courses for young engineers. These are items, I'm saying, just like you can't learn swimming without a swimming pool, you can't learn these things unless you play around with things with your own hands. And I've seen engineers, soon as they do 1, 2, or 3 things, they are totally different compared to what they were before. This is where we want to reach. This is where we want to take our engineers. And I think the first demo we will do is day after tomorrow at on the 15th at the Acrex exhibition. So those of you who are listening would like to come along, it's from 2:30 to 5:30 in the afternoon. Please find your way. It's a walk-in. Come and have a look at all that I have talked about.
Thank you, Mr. Goel, for sharing and highlighting the significance of HVAC energy efficiency and IoT technology.